Okay, we should be live. I don't know why it still says upcoming. Still, it is working. Just share it on. Oh, tweet is so bad. We'll share it on Twitter and then quickly get out. And LinkedIn is also pretty bad, but not as bad. And just want to check it on another device. Actually working. Okay, it's not refreshing. Okay, now it's there. Just check the sound in real time. Make sure the proper microphone's right. This way I can also monitor the chat if anyone has any comments, suggestions, etc. We would not be looking at YouTube analytics. It's not very great interface anyway. Thinking redoing it somehow. Still, for whatever reason, don't have ads on the website. Sorry, I'm losing my voice. I didn't have my voice for a couple of weeks. Now it's back. Now it's back, but not 100%. My oop. Right, so I have, where is it? This way, the new logo. Might need some more light. Getting dark outside. Yeah, don't have proper light in here, but it is what it is. And on this side we have my machine. To mute my phone. Right, so as I mentioned yesterday, we have this new website going on. Currently working on this too. This one we did covered pretty much yesterday. This will use your microphone for audio transcription, and we'll do some speech analysis, pretty basic. We might improve on it later on. You can see how well or badly the transcription is working. Yeah, it's not great, but actually with this mic, check that it's using the correct microphone. Yeah, it is. That will show you the speech rate. It's mainly for myself. And we'll do volume analysis. And this is actually all the comments, not all selected comments from ChatGPT that help me generate this. And yes, it will only work in Chromium based browsers. It's good to know. I didn't know it to begin with, but yeah, only works if you're on Chrome, Edge, or Opera. So it doesn't work in Firefox or any other browser. Yeah, so that transcription is still going. I don't know what that bit is hidden there. I have to fix it later. And also, yesterday, also trying to fix what happens to this text box when it's too large. Someone joined and left. That's okay. Not everyone's cup of tea. Interestingly enough, I do have views for other videos increasing, especially when I'm live. So that's great. And this is just to repeat everything I said so far.
Okay, this will use your microphone for audio transcription and we'll do some speech analysis. Pretty basic. We might improve on it later on. They can see how well or badly the transcription is working. Yeah, it's not great, but actually this might check that it's using the correct microphone. Yeah, it is. Show you the speech rate. It's mainly for myself. And we'll do all volume analysis and this actually hold the comments, not all selected comments from JP that helped me generate this. And yes, it will only work in Chromium-based browsers. It's good to know. Didn't know to begin with, but yeah, only works if you own Chrome, Edge, or Opera, so it doesn't work in Firefox, so any other
I probably should stop saying yeah so much. There's a description here, some comments from ChatGPT, as I mentioned, for this tool, and there's some suggestions of how you can improve it. So we might get to it probably another day, unless someone else wants to help me with this. That would be great as well. Go back to and there is also a lot of error detection here in HTML. So when the transcription stops for whatever reason, not sure. Sometimes this button meant to turn red, but sometimes it won't. But it will give you HTML will inject the error message in here in your developer tools. And again, you have to only use it in Chromium-based browsers. But today we'll do something else. This is also up and running on the side to replace this Plotly bar chart example, and it's a simulated ECG and with its components being measured. But this obviously needs more work. First of all, this doesn't look a lot like ECG. I mean, it has the Q complex and sorry, not Q, B and T, and the QRS doesn't look anything like a real QRS. So we will try to fix that, and this is what it does.
Design ECG waveform function. Create a function to simulate the basic PQRST pattern of an ECG waveform using mathematical functions. 2. Refine the ECG waveform. Update the waveform function to make it more representative of a real-life ECG waveform.
Obviously, we need to do it a couple of times. This one actually, this is what it generated to begin with, and that's an improved version. So yes, it is a lot improved. I would probably improve it the third time, make the Q peak actually a peak, a spike, instead of this sine wave. Now it keeps simulating everything with sine waves.
Waveform. 3. Measure and quantify ECG components. Determine the amplitude of the P wave, QRS complex, and T wave. Initially, set error margins for these measurements. Later, generate multiple QRS complex variations and calculate a precise error margin based on these variations. 4. Store ECG data.
Right, so this one will be generating multiple, like here, multiple QRS complexes with, just adding noise to it, having multiple variability, and then plotting the bar charts of the measurements on the peak. We don't have it here. like so, like the P wave QRS complex amplitude. So amplitude for 3 of them, and then also light another one for distances between them. Yes, and hopefully it will look more like this.
Data asterisk asterisk. Save the ECG waveform data in a separate JavaScript file, ECG_data.js. Store the variations of the QRS complex in a JSON file, QRS_data.json. 5.
So no idea why it's saving the ECG waveform in a JSON, in a JavaScript file, and the other data, the QRS complex in the JSON. Here we have this folder here. So that's what the ECG data looks like, and that's what the QRS data looks like. I guess those are the bar charts. There's a lot of zeros in there. Don't know why. So I'll try to fix this. This is the HTML code.
Data in a separate JavaScript file, ECG_data.js. Store the variations of the QRS complex in a JSON file, QRS_data.json. 5. Develop an interactive visualization. Utilize Plotly's JavaScript library to display the simulated ECG waveform. Overlay the multiple QRS complex variations on the main waveform. Design a bar chart to show the ECG component amplitudes and their error margins, even if it's not directly shown in the HTML.
Oh.
Develop an interactive visualization asterisk asterisk. Utilize Plotly's JavaScript library to display the simulated ECG waveform. Overlay the multiple QRS complex variations on the main waveform. Design a bar chart to show the ECG component amplitudes and their error margins, even if it's not directly shown in the HTML. 6. Add contextual documentation. Insert explanatory text alongside the visualization to explain the displayed data and the importance of the ECG components. Overall objective: develop a tool that simulates, quantifies, and visualizes ECG data in an interactive and educational manner.
Right, so it's breaking it into the different components. We have the Python code that is currently, we don't have a copy for this. It's pretty basic, using mathematical equations to simulate those waveforms. I mean, in this case, it's just providing this. Might as well drop it and go for the second one, which is obviously better. I don't think you need the first one. What do we have in there? Just create the new Python file. Let's save it. So I want the code that's generating ECG. So let's call it Python. I don't think we actually need this one. Yeah, it's running okay. We might as well just go for the second one. Just another function. Plotting as well. Might get rid of plotting. Might not need this as well. Run this quickly. Running, no. We had to close this. We do need this bit in here. do have the... Oh, come on. Okay, sorry, let's start again. Sorry for that. Copy this, make sure running, yes. Have the improved function. Make sure it's running. Yes, so we have that fine ECG waveform. We don't need the first plot. Why refined? We don't need this. Only need that. Right again. Okay, this is running. Okay, I deleted something before there by mistake. We can get rid of all that. Right, it's pretty much it. Now, do it in the same file. That's not calculating. Let's be print. I don't know. Leave it at that. Now, this is using, should be using refined ECG waveform, generating multiple, like 3 variations of it. But it's actually, yes, ideally we'll have this function with an input for QRST values, and then we use the same function multiple times, because yeah, this is no good. Yeah, not using that function will still grab it. Right, so it's plotting this.
The variations of the QRS complex are shown above, overlaid on the original waveform. The variations are: dashed line, taller R wave; dotted line, broader R wave; dashed dot line, deeper Q wave. To determine a more precise error margin, we can measure the differences in amplitudes of these variations compared to the original QRS complex amplitude. Let's calculate. Hide work. Python.
Yeah, we need that as well.
Based on the variations of the QRS complex, the precise error margin for the QRS amplitude is approximately units. 4. Store ECG data. We will.
Yes, again, I don't know why in this case we're using JavaScript. Looks JavaScript. This one JSON. I mean, they both look the same. Anyway, this is saving all the data. We can instead of downloading it off ChatGPT, we'll just generate them here. Let that works. Getting an error. Right, that's some sort of folder for the ChatGPT. I have to change that. I want them in the same folder. Sorry, I have my cup in the way. We'll just do this. We'll generate this again. We have that. We have this with all the variations. And we updated the JSON file and the JS file. Let's check that they were actually updated. Um, I think they were they? Um, sure. Let's see.
For the interactive visualization using Plotly's JavaScript library, we would typically need a web environment to implement and display it. However, I can provide you with a template code that you can use in your own web development environment. Below is a template to help you set up an interactive visualization using Plotly's JavaScript library.
Okay, so I have a similar code here before. Wait, all this stuff should be in a JavaScript file. Okay. No, that's okay. Copy it in here. And it doesn't work. Let's check for any errors. We have one error. ECG data is not defined. ECG data is not defined. This one here. Make sure we're calling when do we call
This template is a starting point, and you can expand upon it based on your requirements. Use this code in conjunction with the previously generated ECG_data.js and QRS_data.json files. Simply host these files on a web server.
Yeah, that's fine. Where's the JS? Wait, JS? No, that should be a data file. ECG. I think it might be able to fix this. Yeah.
Error uncaught. In promise. Reference error. ECG data is not defined suggests that the JavaScript variable ECG data is not accessible or hasn't been defined before it's being used in the promise. Here are some steps to troubleshoot and fix the issue. Order of scripts. Ensure that the ECG_data.js script is loaded before any other script that references ECG data. Path to ECG. ECG_data.js. Make sure the path to ECG_data.js is correct. If the HTML and the JS file are in the same directory, then the path you've given should work. If they're in different directories, adjust the path accordingly.
They are in the same directory.
Variable declaration in ECG_data.js. Open ECG_data.js and ensure that the ECG data variable is declared at the global scope. The file loading. If you're loading scripts asynchronously, it's possible that the main script runs before ECG_data.js has finished loading. Make sure the main script waits for all resources to load before executing. Browser cache. Sometimes, the browser may cache old versions of scripts.
Good idea. Control 5. No, that didn't work.
Scripts. Try clearing the cache or doing a hard reload, usually Ctrl plus F5 or CMD+R. Console logs. Add console.log ECG data right after the script tag for ECG_data.js to see if it's being loaded correctly. JavaScript console. Open your browser's JavaScript console to see if there are any other errors or warnings.
We want this console log. After this, why is this in a separate script? Just have this in the console, need to be in a script, and comment this out. Yeah, ideally for better troubleshooting, we should have this in a separate. In a separate file. I don't know what the problem with this is. It's loading the data from ECG data. It's loading this data. Doesn't work. Reformat this. so it's easier to troubleshoot this console. Log working? No. It says not defined. Pop this whole thing.
Your provided HTML content, you've commented out the script tag that imports ECG_data.js. However, you tried to include it in the script block by using src equals ECG_data.js, which doesn't load or execute the JavaScript from the external file. To resolve the issue, uncomment the script tag that imports ECG_data.js.
Okay, so it says we need that bit. Don't need this.
Remove or comment out the line src equals ECG_data.js in the script block as it's not necessary. Make sure the ECG_data.js script tag is placed before the main script block, so the ECG data variable is defined before it's used.
Script tag. Yeah, this one.
A .js script tag is placed. For making these changes, your code should work correctly as long as ECG_data.js and QRS_data.json are in the correct paths and contain the expected data.
Are they in the correct path? They are the same path. Yep. One is loading. Okay. Okay, what's wrong? Load it again and give it the error message. That should be something simple to do with the folder.
Version of your HTML looks correct. The ECG_data.js script tag is placed before the main script block, ensuring that the ECG data variable is defined and loaded before it's used in the main script. Make sure of the following. Both ECG_data.js and QRS_data.json are located in the same directory as your HTML file, or adjust the paths in the script tags accordingly if they are in different directories. The ECG_data.js file should contain the ECG data variable defined as. Accordingly, if they are in different directories. The ECG_data.js file should contain the ECG data variable defined as.
Wait a sec. This ECG data. The variable is called. Oh, the variable is called ECG data. So let's just check. The Python code should have generated this. Can I rename those files for a sec? In the folder, these two files, just copy those and get rid of the original ones, just to see that they are regenerated correctly. and they are not. One is not writing the file. Not generating files. The following code not generating files.
Arise from the
Right, this is wrong. Let's wrote them into, did it? To the main folder? No, it didn't. Right, now it's writing them into the main folder. So I write them into the same
some
folder.
environments may restrict
Wait.
writing files outside the current directory or the designated directories for security reasons. However, in this interactive environment, I can generate the files for you, but they will be saved in the /m/data/ directory. You can
No, I don't want to generate them. What do it's place them in here. Just copy them for now. Okay, this folder is called the right name, ECG data. Right, now it's working. So this is nice. I don't know why the Python code will not write into the correct folder. Write into the same folder where the Python file is. Let's keep generating stuff. No, I don't know, it happens quite a lot. So I wanna modify this goes quickly. Give me a minute. No. No, forget this. Yeah, don't want to download. The download thing doesn't work properly. I want to change this. Instead of writing into the parent folder, this should be writing them into the same folder. And delete this too. Anyway, I'll try fixing it later, but the tool does work. Right, this scaling of the screen wasn't scaling before. Yeah, it's not responsive, it's only scaling on refresh. That's okay. Now, this should be um, so it should be calculating the amplitude for something wrong. It's not right. We did make quite a lot of progress. The tool is up and running. So we're generating a ECG. So there's few issues with this. First, I don't know why this one is cut. Oop. The second chart, you would expect it to also go up to 900. So why is it cut? But let's try something else. We'll start a new. Yeah, we kind of ChatGPT after a while kind of losing its losing it. Almost used the swear word. Don't want to do that. What we will do is go to the original folder. Out of all this, we put it in a zip file, then we can upload it onto GPT-4 code interpreter. Nice. Then this as is. If it's giving us anything useful, yeah, how can I say it? Just well, what do you think? How about open it? Uh, yes. So it's interesting how, yes, sometimes So yeah, I guess this is the main advantage of the code interpreter. I wasn't actually using it mostly. There's all sorts of issues with this, but it opened, managed to, yeah, just running Python um, on the server, which is nice, but it's extracted the files. Oh, it's also, there's a few issues with that, like losing the files after a while. So I don't know if there's like a timeout. With index, do we want to do? Can just suggest improvements. Suggest improvements. Yeah, we need to have this window in the same length as that one. You want to check this amplitude. This arrow bar doesn't seem right. Seems to be too large. As if the original, the average is 1.5. Oh, and we have that variation as well, which is the flat line to 0. That's not good. We also want this to look more like a spike. Now that's okay. I can delete. It's definitely better than what we had yesterday.
This is a Python script which might contain logic related to ECG processing or analysis. I'll review its code.
So someone's asking me to speak louder. I can't actually. I'm losing my voice. That's why we have this to read things out loud.
ECGtool.py. This is a Python script which might contain logic related to ECG processing or analysis. I'll review its code. ECG_data.js. This is a JavaScript file, possibly containing logic related to the display or processing of ECG data on the web page. Info.txt. This might contain additional information or metadata. I'll check its content. QRS_data.json. This is a JSON file, likely containing data related to QRS complexes in ECG. I'll check its structure. To start, I'll display the content of each file, within reason, for a quick review.
Alright, so the info text is actually displaying what we did prior. So this is what we have so far. Sure. Let's get it to do its. What? Where did it go? Yes. Oh, yes. Whatever. It's generating Python, opening all this fast. That's okay. One just will give the same thing as we had before. That's fine. Well, eventually I have some sort of description like this on the page itself. So if you go currently to binarychaos.com, this is what you would see. It's just the demo. It's not great. We will, after, by the end of this stream, hopefully update, load a much better version of it. So what it does is in this description, you can actually go info. Can go info. No, you need the txt. Right, we'll show you the description here. Yes, go for it.
Design ECG waveform function. Simulate the basic PQRST pattern of an ECG waveform. Refine the ECG waveform. Make the waveform more representative of real-life ECG waveforms. Measure and quantify ECG components. Determine the amplitude of the P wave, QRS complex, and T wave. Set error margins and refine them. Store ECG data. Save the ECG data in ECG_data.js and the QRS variations in QRS_data.json. Develop an interactive visualization. Use Plotly's JavaScript library to display the waveform, overlay QRS variations, and show a bar chart of component amplitudes and error margins. Add contextual documentation. Explain the displayed data and the importance of ECG components. Overall objective, develop an interactive and educational tool for ECG data. With this overview in mind, we'll review the individual files to see how they align with these objectives and identify areas for improvement. It's a standard HTML document with a reference to Plotly's JavaScript library. This aligns with the goal of visualizing ECG data interactively. There are 3 designated areas for plots. ECG plot, likely for the ECG waveform. QRS overlay plot, presumably for displaying QRS variations over the main waveform.
Is Python coder still here?
Amplitude bar chart, probably for the bar chart showing the amplitude of ECG components. The ECG_data.js script is included, which should contain the ECG waveform data. There's a script section that appears to fetch the QRS data from the QRS_data.json file and subsequently plots the ECG waveform. From the content provided, we can't see the complete JavaScript logic or any contextual documentation that might accompany the visualizations. To suggest improvements, I'll need to analyze the complete HTML and the associated scripts. However, given the volume of code and data, we might want to tackle this in parts. Would you like me to continue examining the HTML and associated scripts, or would you prefer a different approach?
Yeah, we'll take a different approach. So we have issues with the error bars. So the Python script that generates those that generates the data Can you review the ECG tool Python file? Mainly focus on how data is being stored and also the shape of the ECG. So the shape. Difference between what's the difference in the stop generating button? Yeah, current directory. Yeah, that's right. So this should work for the current directory. Just test this. No, we'll test it later.
Waveform generation. The script creates a refined ECG waveform that consists of the PQRST pattern using mathematical functions. This waveform is generated using NumPy for a single cardiac cycle. There are specific functions to generate the P wave, Q wave, R wave, S wave, and T wave. Waveform visualization. The generated waveform is visualized using Matplotlib. ECG component amplitude measurement. The amplitude of the P wave, QRS complex, and T wave are determined from the generated waveform. An initial error margin is also set. QRS complex variations. 3 variations of the QRS complex are defined and generated. Taller R wave. Broader R wave. Deeper Q wave. These variations are visualized alongside the original waveform. Error margin calculation. The script measures the amplitudes of the QRS variations and calculates an error margin based on the differences between these variations and the original QRS complex amplitude. Data storage. The ECG waveform data is prepared to be saved in the ECG_data.js file. The QRS complex and its variations are prepared to be saved in the QRS_data.json file. However, there seems to be an issue with the paths /ECG_data.js and /QRS_data.json where the data is being saved. These paths may not be valid, and it might be the reason why these data were saved in the root directory as seen in the uploaded zip file. Areas of improvement. Data storage. Correct the paths where the data is being saved. It's better to use relative paths or paths that point to the correct directory. Code modularity. The script can benefit from a more modular approach. Breaking down the code into smaller functions and organizing them by their functionality can make the code more maintainable and readable. Error handling. Implementing error handling, example, try except blocks, can help manage unexpected issues, especially when working with file operations or mathematical operations that might fail. Comments and documentation. While the script has comments, it can benefit from more detailed comments and docstrings for each function to explain their purpose and any assumptions made. Optimization. While the script has comments, it can benefit from more detailed comments and docstrings for each function to explain their purpose and any assumptions made. Optimization.
Can you explain what are you doing? Also, I'm not getting your voice. Try to speak louder. That's not my voice. Actually, I still don't have my voice back. So I can try. Oh, just bring the microphone closer. So what we're generally trying to do is add another tool. Actually, it's a good give some background. So I'm a biomedical engineer. No, let's just fast forward that. So on this side we had a tool that simulates ECG. This is actually a better simulation. Probably have to revert to this. And this was done in a different software. So this was all LabVIEW code. Some MATLAB, maybe. Don't remember. It was a while back. But anyway, so what we are trying to do is have an example of how to simulate biomedical signals and process them. Hope that answers the question. But then, so in here we're writing it all in Python. Guess I could use a Python coder. I don't actually know Python. That's why we're using ChatGPT to do this stuff. But yes, so in the past, so those tools are online. You have to, in red here, you have ECG feature extraction. So that works quite well. It's actually live data in there. Not live. You know what I mean? It's an actual. You mean you want to build AI that tracks ECG? Well, yeah, it's probably some sort of supervised model where you have an expert, someone who actually been looking at those things for a long time. Yeah, being able to detect those. So that's actually working quite well in here. We do have the model for this. Yeah, it's been quite a while back. You can go check it. It's on the website called ECG Feature Extractor. You have this different types of ECG. So this is abnormal ECG, and yes, it's making mistakes here. So for normal ECG, it's working really well. It detects your QRS. I mean, I'm saying it's live, meaning if you load a different data that looks like this, it will work in the same way. This one's just loading a small section. Yeah, it's actually a longer file. Yeah, so you can see how that is working. Actually, so in the atrial tachycardia, go talk to a clinician. I'm not a clinician, so I'm not allowed to actually talk about these things, but you can see here that the detection is not as good anymore. So for example, in the beginning, so in normal, let's just reload this page. It's by default just loading 10 seconds of what's 30 seconds worth of data. This is supposedly real data. So yeah, this is labeled correctly, but when you have abnormal ECG, it starts making mistakes. So we wanna build AI that tracks ECG. Yeah, I mean that will be great. That does it correctly though. That will be the main criteria. Actually, in this case, it improves after sometimes it's only mislabeling the first three peaks, and then it's doing better. I think, yeah, it should be PQRST. Yeah, because that will be the normal bit. And then in hyperkalemia, it's also will probably be stuffing things up. Oh, come on. Ba, 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 ba. Yeah, hyperkalemia. It's where you have the T wave elevated. It's actually doing pretty well. So even though the T wave is above the peak of the R wave, R peak, it's still able to detect that. Okay. But yes, we want it better. We don't want to make mistakes. We want to have a tool that you're able to actually test what it's doing, not a black box. So in this case, yeah, I don't actually remember what the model was. Pretty sure I have the source code for it. So it's a deterministic model. So not AI. It will be like fuzzy logic type of based. So yeah, not sure how do we define AI? ML, machine learning. Well, okay. Or just machine. We might stick to the learning as humans and let the machine do machine things. Anyhow, back to to this new tool. Um, so this is what we have online at the moment. This is our prototype. It's definitely better. There's a few funny things there. Know why I decided to cut off the x-axis. Yeah, if you have any suggestions of how to do it better, or uh, please do let me know. There's also seemed to be a mistake mistake in this error bar. Yeah, it's definitely a mistake because it's like plus minus itself. Actually, yeah, because we had that first. So we asked, so the Python code is generating the same. Yeah, we actually have to improve on it a lot on this Python code. To begin with, yeah, I want this function with, yeah, just putting all these waves together, which is fine. Most of them are sine based. I'll probably have the R wave, like the peak, have it an exponential thingy. So the R wave, let's actually do that. They should probably write some code. Yep, Talent Shop away should not be sign based. Oh, come on, just hit full screen. Yeah, let's see what it says because why should I write some code if ChatGPT can do it for me?
which represents ventricular depolarization, is typically the most prominent wave and has a sharp spike-like appearance. Using a sine function might not be the best representation. Stop generating. Better approach would be to use a function that mimics the shape of the R wave more closely. Gaussian functions or other similar bell-shaped curves can be a better fit for this purpose, as they produce a sharp peak which can resemble the R wave. Let's modify the R wave generation using a Gaussian function and compare it with the original sine-based R wave.
Gaussian, I thought will be like two exponential functions will be better, but it got an error. It's fine when it's getting an error for its own code, and then it's trying to fix it as well. So, still working on it. I'll be just taking 5 minute, a couple minute break, so I don't entirely lose my voice. This one keeps getting errors anyway. So yes, we'll probably have to start from scratch. Right, it's actually is better. It does look more like a spike. Uh, well, yeah, is the Python code that says Yeah, what should you do? Write some code? Well, I don't think I'll ever be able to write anything better than this. So this one keeps getting errors. It didn't manage to fix the errors somehow and actually plotting results. And yes, it's definitely better. Right, so it's only fixed the Gaussian, the R wave. So we'll need to add it to everything else, which would be fairly straightforward. So yes, it did do better.
Here's the comparison between the original sine-based R wave and the Gaussian-based R wave. The blue line represents the original sine-based R wave. The orange dashed line represents the Gaussian-based R wave. As you can see, the Gaussian-based R wave provides a sharper and more realistic representation of the actual R wave found in ECGs. This approach more closely mimics the rapid depolarization of the ventricles.
That's pretty good. Yes, we want to proceed with this. Don't want to try something else because it's doing really well. So this is what it generated to begin with. So I need to fix this thing, but that's a minor thing.
Proceed with further improvements to the ECG waveform generation and the overall tool. Integrate Gaussian-based R wave into the ECG waveform. First, we'll modify the refined_ECG_ waveform function to incorporate the Gaussian-based R wave instead of the sine-based one. This will provide a more accurate representation of the ECG waveform. Improve amplitude measurements. Currently, the script determines the amplitude of the P wave, QRS complex, and T wave based on approximate regions of the waveform. We can refine this by identifying the exact peaks and troughs in the waveform. Enhance QRS variations. The script currently defines 3 variations of the QRS complex. We'll ensure these variations are also based on realistic changes that can occur in actual ECGs. Data storage enhancements. We'll ensure that the generated data is correctly prepared for storage in the associated JavaScript and JSON files. Visualization improvements. While the script currently visualizes the ECG waveform and its variations, we can add more features, such as annotations, to make it more informative. Let's start by integrating the Gaussian-based R wave into the ECG waveform and visualizing the updated waveform.
Yeah, because it's only generated the R wave. We need to integrate them all together, but it looks like, yeah, if you just get rid of that one, have this one instead, it will look better. Also not sure what's happening here. To check P wave. Can it also plot them all in different colors? Where's the actually no, right, it is the refined ECG. Q wave is the same. Copy it underneath to see if it's the same or not. That's the same. Right, this S wave is a bit funny. I have to work on that. Right, so this is obviously different, so we can comment the previous one out. S wave should be the same. Just what? Where's that guy from? Uh, refined R wave. That's weird.
Comparison between the original and updated ECG waveforms is displayed above. The blue line represents the original waveform with a sine-based R wave. The orange dashed line represents the updated waveform with a Gaussian-based R wave. As can be seen, the updated waveform with the Gaussian-based R wave provides a sharper and more representative depiction of the R wave, making the ECG representation more realistic. Refine the amplitude measurements for the P wave, QRS complex, and T wave. We'll identify the exact peaks and troughs in the waveform to more accurately determine the amplitudes.
Um, that's the original. Where's the Gaussian based? Gaussian based? Gaussian function. Doesn't look like it. There's something wrong. Can you generate the Python script with the Gaussian wave? Gaussian R wave. Yeah, so it didn't show me this function before. Yeah. It's generating. I don't understand how it's actually available. If we have it in download to call it new, place it in the same. I need to combine this two. I'll just call it ECG waveform. Have the ECG waveform. Right, we need these two. Then ECG waveform, this should be the same. And this one here. Why is this grayed out? This wave T wave is the same. Wave Gaussian. Right, because it's not being used. That's pretty handy. I didn't see that before. So that's how much Python I know. I mean, it's nothing to do with the language as well. It's the development tool, so the Visual Studio Code thing. Right, so we have that now. And this should be the same. And the thing at the end should be storing it into the current folder. Let's see if that works. Don't save. We can delete it in a bit. And this. Right, so it's generated that. So that's fine. Yeah, it's probably going down way too much, but it's good that this looks more like a QRS. Probably have its amplitude a bit larger, but that's okay because we are varying it eventually. This is not the variation. Don't know how this variation 3 is of any use. It's just a flat line. this thing is still writing into the main folder. Oh, come on. Into the same folder. Right, this is the kind of stuff will drive you. Regenerate response.
Hello, this is Bing. I'm glad to assist you with your questions. And are symbols that indicate relative file paths in programming. A file path is a way of locating a file or folder on a computer system. Stands for the current directory, which is the folder where your program or script is running from. For example, if you have a file named main.py in a folder named project, and you run it from there, then main.py means the same file. Stands for the parent directory, which is the folder that contains the current directory. For example, if you have a file named data.csv in a folder named data, which is inside the project folder, then data.csv means that file from the project folder. You can use these symbols to access files or folders that are related to your current location without having to write the full absolute path, which starts from the root of your drive, such as C:\/ or. You can find more information about file paths and how to use them in different programming languages from these links. How to use Python file path with VS Code by Charles Shear.
Okay. Still not. Do I need to delete them? Does it check? Keeps writing them. Get it. How to check where is the current file is, as in the folder.
Searching for how to check where is the current file is as in the folder. The current file is the file that you are running or executing on your computer system. The current directory is
In Python.
If you are using Python, you can use the OS module or the pathlib module to get the current file and directory. For example, you can use the following code to print the current file and directory. Import OS, import pathlib, get the current file. Current_file equals os.path.abspath file.
Turn this into the current folder where the Python script is located. Oh, come on. Where the Python script is located. Oh. Right, might finish it another time. Just say bye bye now and keep going as per usual. Just get ChatGPT do something in the meantime. Just place all the files we're working with in a zip folder, upload it again. And ask it to open the zip folder, explain the files, and suggest improvements. yeah, considering what we had to begin with and what we have now, is definitely an improvement. What did it suggest doing?
Separation of concerns. The inline JavaScript code should ideally be moved to a separate external script file, making the HTML cleaner and more maintainable. Error handling. The current script doesn't seem to have any error handling for the data fetch operation. This could be enhanced with .catch, blocks or try-catch statements. Additional features. It would be beneficial to add interactive features like zooming, panning, and tooltips for a better user experience. Plotly does provide some of these features by default, but they can be further customized. Styling. There is no CSS linked or inline, which means the visuals might be quite basic. Adding some styles would improve the user experience. Next, I'll inspect the contents of the ECG tool.py. Seems to contain a Python script designed to generate and visualize a synthetic ECG waveform for a single cardiac cycle. Here's a brief overview of the contents. Imports. The script imports NumPy for numerical operations and matplotlib.pyplot for plotting. Functions. Gaussian, x, mu, sigma. This function generates a Gaussian, or normal distribution, function value based on given parameters. The Gaussian function is used to model the shape of certain ECG waveform components. Refined _r_ wave, t, mu, sigma, amplitude. This function generates the R wave, a prominent peak in an ECG waveform, using a Gaussian function. The shape and position of the R wave can be controlled with the given parameters. ECG _waveform, t. This function seems to generate the entire ECG waveform for a single cardiac cycle by combining different waveform components like the P wave, Q wave, and R wave. The snippet cuts off before displaying the entire function, so we can't see all the components it generates. Suggestions for improvement. This function seems to generate the entire ECG waveform for a single cardiac cycle by combining different waveform components like the P wave, Q wave, and R wave. The snippet cuts off before displaying the entire function, so we can't see all the components it generates. Suggestions for improvement. Comments. While there are some comments present, it would be beneficial to add more detailed explanation.
My text to speech like stops working, stops responding. It's the inbuilt into the browser, but yeah, good luck. Oh, come on. Actually place this in the right. This is what we are primarily interested in. Oh, it's all okay. Wait, did I have another? Did I have another ECG? Right, right. No, this is really confusing because this JSON file is actually the data, and the actual JavaScript file is actual data. There's no actual JavaScript. The Python does the code. It's not storing in the correct folder, which was driving me nuts. Yeah, JSON is JSON. And there's also some JavaScript inside the HTML. That's for plotting the chart. Sorry. Um, yeah, that's not what I'm interested in. I want to know why the second plot is being cut off, and also why the third variation is showing this weird thing. So many concerned about this patent code. So okay, let's start over. Will be last attempt for today. Yeah, there's a few questions. Yes, we have want to label those. Move to that later. So we have 1, 2, 3, 4, 5. 2, 3, 4, 5. Yeah, that's okay. Why is the this two the same? No, they're not. Okay. Yeah, no, I want to do something else. So that's okay. Then we have this one. So in the display is being cut off. That's actually, wait, let me check. Check this again. The time is 16 seconds. Right. The time here is also 16. Question. Why? Right, so this is just fake. So in the HTML, let it finish generating. Fix the x-axis to be the same as in the Python script. Placeholders in the script. I didn't notice them before. Let's read the whole thing.
Includes the Plotly library. The Plotly library is imported to provide the plotting capabilities. Plotly is a popular visualization library that can produce interactive charts. HTML structure. 3D IV elements are created to hold the ECG waveform plot, the QRS variations overlay plot, and the ECG component amplitude bar chart. JavaScript. The ECG data is loaded from an external JavaScript file, ecg_data.js. The QRS data, original and variations, is fetched from the QRS_data.json file. 3 plots are created. ECG waveform plot displays the overall ECG waveform. QRS variations overlay plot, overlay of the original QRS complex and its variations. ECG component amplitude bar chart displaying the amplitudes of the P wave, QRS complex, and T wave with error bars. There are a couple of placeholders in the script. In the amplitude bar chart, the Y values are placeholders for the actual amplitudes of the P wave, QRS complex, and T wave. In the error bars for the amplitude bar chart, the array values are placeholders for the actual error margins. To fully integrate this with the data generated earlier, you should replace the placeholders with the actual values.
Yeah. I need the values though. X-axis in the first 2 charts. It's not the same.
Fix the x-axis of the first 2 charts to match the x-axis values from the Python script. You should provide the x values, i.e., the time values, to the plotting functions in the JavaScript code. Here's how you can modify the plots. ECG waveform plot.
Okay, first with JavaScript is in the HTML. ECG plot. By what? Yes, this is going up to 14. Yes, I think it is the same as the Python script.
This code generates X values for the QRS data, taking into account that the QRS data starts from January 5th th of the total ECG data and ranges to of the total ECG data length. With these modifications, the X-axis values in the plots will match the time values you used in the Python script.
Why would it be different? Different. Should be the same as that. Error. Ok. Going up to 6. Name everywhere. No. Make the x-axis the same on both charts.
make the x-axis consistent across both charts, I've made the following changes. Remove the separate QRSX calculation. Instead, I've used the same x-value generation, i.e., array.from length ECG data.length underscore I equals I asterisk 5 asterisk math.pi slash ECG data.length 1 for both the ECG waveform plot and the QRS variations overlay plot. Commented out the old QRSX calculation to keep the script cleaner. Here's the modified part of the script. This modification ensures that the x-axis values for both charts are consistent, ranging from 0 to. When you view the plots, the x-axis values will match those used in the Python script.
From this bit. First chart is going up to 15 and the second chart goes only up to 6. 7 or whatever.
The first chart, ECG waveform plot, displays the full ECG waveform, while the second chart, QRS variations overlay plot, is showing only the QRS section. Due to this discrepancy in the range of data being plotted, the x-axis scale is different between the two charts. To fix this, you can adjust the x-axis range for both plots to be consistent. Here's how you can make this adjustment. Define the range of x values for both charts. Set the x-axis range using the layout property for both plots. Here's the modified code.
Okay, now the charts are the same. The second chart should show the whole PQRST.
You want the second chart, the QRS variations overlay plot, to display the entire ECG waveform, including the PQRST sequence, for each variation. To achieve this, you simply need to plot the entire waveform, including all variations of the QRS complex, on the second chart. Let's modify the code to do that. Here's how you can integrate the full waveform. Make sure that in the QRS_data.json file, the data for each variation, original, variation_1, variation_2, variation_3, contains the entire waveform, PQRST sequence, with the respective QRS variations integrated. This will allow the second chart to display the full waveform for each variation. Regenerate. ChatGPT.
I need to fix the Python code for this as well. Do I need to fix the Python code as well? Yes, because
Define a function to generate the full wave. JSON file contains only the QRS section data and not the entire PQRST sequence for each variation. Then yes, you'll need to modify the Python code to generate the full PQRST waveform with each of the QRS variations. Here's how you can adjust the Python code. Define a function to generate the full waveform with each QRS variation. Adjust the data generation for the QRS_data.json file. With these modifications, the QRS_data.json file will contain the entire PQRST waveform for the original and each of the 3 QRS variations. This will allow the second chart in the HTML to display the full waveform for each variation.
yes, I did understand what I want. ECG. The variation 1. And that third variation needs to be fixed as well. Thing is, thing needs to be I don't want any magic numbers in it. I want regenerate the whole Python code to be regenerated. I want it to be fixed. This variation. Yeah, that's not how I want to do it. Regenerate the whole Python code. The same so far. What's that? What? It's something there. I'm not sure what it's trying to do. I didn't. Well, I didn't like those Q waves anyway. Yeah, those variations. Don't like them either. Give it a go. Working okay. Yeah, the deeper Q needs. I would expect it to still have the R peak, the deeper Q wave.
Here's the complete Python code that generates the entire PQRST waveform with each QRS variation. Code will generate two files. ECG underscore data.js contains the original PQRST waveform. QRS underscore data.json contains the entire PQRST waveform for the original and each of the three QRS variations. These files can then be used in your HTML for visualization. Regenerate. ChatGPT may produce it.
Right. This is better. Right, so the variation is only on the R complex. Don't like that variation 3, but okay, leave it there as it is for now. The other thing I was trying yesterday is giving it code and asking for a prompt that generates this code. And that seemed to do something useful, potentially. Yeah, all those are the same. It's very good. Yes, you do want to add some interactive stuff to it. Just try fixing this last thing. Understand. So I'm currently in this folder. Um, this is not writing the file into the same folder where the Python script is in Visual Studio Code. Because my folder here is set to Bionic Chaos, but there's a subfolder.
Working directory of a script may not necessarily be the directory where the script is located. Instead, it could be set to the root directory of the open folder/workspace. To ensure that your files are written to the same directory as your script, you can use the OS module to get the directory of the current script and then construct the full path to your target file. Here's how you can do that. Import the OS module. Get the directory of the current script using os.path.dirname, os.path.realpath, __file__. Construct the full path to your target file by joining the script directory with the desired file name using os.path.join.
Okay, let's try. Yes, let's import another module. That's okay. Before And let's try this now. Auto decay. Yeah, this is working. Okay. And it's 64. Still the same. Okay, this is handy. Handy. Very handy. So I think it's a winner for today. Might give it a rest. It's interesting. In LinkedIn, I got a notification. Let's say, oh, you are invited to contribute to collaborative article. It's actually looks like it's. I don't know who they invite us from. Like it's from LinkedIn. Actually, quite interesting. So I guess it wasn't published yet, obviously, because it's still being written. It's on how can you blah, blah, blah. Yeah, but it's an interesting concept of how to write an article together. And it has sections where supposedly I'm invited to add my um, perspective. Yeah, it's okay. I might do it just for the sake of trying it out, contribute something to it. Okay, I'll see you next time. This tool should be live in here. We'll generate a new thumbnail for it. And we'll go from there. Please don't forget to subscribe to my YouTube and check out my Patreon as well if you like. Bye.